All right, so you're going to have to get a piece of paper and a pencil, and you're going to be drawing down these schematics. We have 1, 2, 3, 4 questions that I'm going to ask you guys to answer. I'll do the first one as an example for you, but let me give you an opportunity to write down, to draw these down. So we're drawing number 1 there. We have a schematic that has 2 resistors, and they're both in series. E is our voltage total. R1 is the resistance for R1. R2 is the resistance for R2. So what they're asking you to find are RT, IT, the voltage drop to push through R1, and the voltage drop to push through R2. So let's do this one together, okay? Get this drawn down first right now before I move ahead. Pause it if you need to. I'm going to go around all 4 and have you write them down, and then we'll go back and do number 1 together. So that was number 1. Number 2, same thing, series circuit with 2 resistors. Our knowns are the voltage drop to push through R1, the voltage drop to push through R2, and also IT, which is just labeled as I here. You need to find the voltage total, the resistance of R1, the resistance of R2, and the total resistance. Okay? This is slightly different than how we have drawn it in class, where that right there is how they're drawing it in the book here. In class, we have drawn it as power supply comes up, negative, positive, R1, R2, and for I'll finish this up for the first one for you. That's number 2. Have that written down. So you'll have in your responses for number 2, which is the first one you're going to be submitting to me. So you'll be submitting 3 different sets of answers. You'll write number 2. ET equals, and tell me what your answer is. R1 equals, R2 equals, RT equals. And then you'll go to number 3. You will not have number 1 labeled because that's the example that we're going to do together. So the next one is 3 resistors in series, where they're giving us as knowns R1, R2, IT, and the voltage dropped across R3. What they want are the total voltage. When they have E3 here, it's kind of a trick question because E3 and ER3 are the exact same thing. So the answer for that one is going to be 200 volts because it's just a different way of writing the same thing. E3 is the voltage dropped with R3 because it's the third load. RT and the voltage dropped across R1. And your third question, so you'll label it number 4. We have 3 resistors in series again, where they're giving us the voltage dropped across R1 is 50 volts. The voltage dropped across R2 is 150 volts. And the voltage dropped across R3 is 200 volts. Okay? We have IT is 0.25. In all of these, I is going to be the most important one for you to answer because at R1, if we're trying to find the resistance of R1, we know what the voltage drop of R1 is. And we also know what the current of R1 is because the current is going to be I of R2 and I of R1 and I of R3 in a series circuit. I, for this particular spot, the current running through these areas here is all going to be the same because IT is the same throughout in a series circuit. All right, so you should have had time now to write those down. We're going to do number 1 as a group here. So I'm going to write down what I know about this on my schematic that I've drawn here. So I know that VT equals 50 volts. I know that R1 equals 50 ohms. I know that R2 equals 150 ohms. So if I know each of the resistance values, I know the theoretical total resistance. So RT in this case here is going to be a very simple matter of just adding up what those two resistances are. 50 plus 150 is 200 ohms. And I apologize for sloppy writing. I'm looking through my camera to make sure I'm on the right thing and writing at the same time, so it's a little bit difficult. IT, which is what they're asking you for with I there, IT is going to have to be done through Ohm's law. So I'm going to need to know what VT is and RT is. So VT, I'll write that here also just so we have that here. VT equals 50 volts. That was a given to us. That's up there, E 50 volts. So I have RT and I have VT. If we plug RT and VT into this, then we're covering up the I, and it's going to be VT divided by RT will give us IT. So VT is 50 volts divided by 200 ohms, a quarter of an amp. So 0.25 amps. And when we're going through Ohm's law, again, I said this before, we're always working with amps, we're not working with milliamps. If milliamps, writing it that way is just a kindness to you, so you're not looking at so many decibels in here. IT, now they're asking for E of R1 equals, well, we know what I of R1 is, right? We just found that out because we found out IT. So I of R1, which they're not even asking for, equals 0.25 amps. I of R2 is going to be 0.25 amps also. It's the same throughout in a series circuit. So I of R1 is 0.25. So we have I in the equation, 0.25. And we know that R1 is 50 ohms. So we have I and R, and we're looking for the voltage drop. So that's going to equal I times R, which is going to be 0.25 times 50 ohms, okay? Which is just a quarter of 50. So half of 50 is 25, a quarter of 50 is going to be 12.5. Let's just make sure that that works out that way. 0.25 times 50 equals 12.5. So E of R1 equals 12.5 volts. And I squeezed that over in the side there. Okay? I'll also write that on my schematic up here too. E of R1 equals 12.5 volts. Now, there's a couple different ways to figure out E of R2. We can go ahead and use Ohm's law again by just covering that up and knowing our current and our resistance of that. But the other way is from process of elimination. We have 50 volts total, and we use 12.5 volts over here. So 50 minus 12.5 is going to be the remainder, and that's what the second resistor is going to be getting. So that's 37.5. So E of R2, 37.5 volts. Let's do that mathematically quick here, though, too. So E of R2 is going to be I times R. I, in this case, is 0.25 times R, which is 150. So a quarter of 150 is 0.25 times 150. 37.5. So 37.5. So the answer's here. So I can make it a little bit more clear here. Number one. RT was we added them up. Our resistance values. We got 200 ohms. IT. We used Ohm's law. We had ET or VT and RT, and we simply divided. And we got 0.25 amps. finding the individual voltage drops here, we went ahead and used our current and our resistor values that were known and plugged them into Ohm's law. So for those two, we got, for R1, we got 12.5 volts. And for ER2, we got 37.5 volts. On the next one here, they've given you what the two voltage drops are. And if we add all of our voltage drops together, what do we get? They've also given you a current total, which is the most outstanding thing that you can have here. Because it's the same. Current total will be the same. Current will be the same at R1 as it is in R2. Okay? So you have number 2, number 3, and number 4 to turn in for this week.